Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Hakimi bin Muhammad ARIFIN. My student ID is 2019229938. So today, I would like to present about our mini project, which is car reverse parking sensor. Before I start my presentation, I would like to introduce my group member first. For our group leader is Ahmad, Kamal, Tajuddin, who will explain about the flowchart and coding for our mini project. Next, ELTIZAM EZWAN will explain about the result and discussion. I, Muhammad Arif Hakimi, will present about the problem statement and objective, while Muhammad ZUHAIKAL will talk about the circuit diagram and conclusion. Last but not least, ALIAH HAZIQAH will explain about our product description and details. Before I start my presentation about the problem statement and objective, I would like to make a short introduction about our mini project. As we know, nowadays, one of the most important skills for any driver is to park their car. This is because it is difficult to measure the space around the vehicle. Therefore, this problem can be solved by using the parking sensor. Parking sensor is a distance sensor that the driver can use to identify the nearby obstacles when parking. Next, I would like to talk about the problem statement for our mini project. We know that parking a vehicle is one of the hardest things for driver, especially parking that requires the driver to park their car in reverse parking. There have been many cases of accidents occur due to reverse parking problems. There are examples that I take from newspaper where they occur due to reverse parking. For example, the deadly child is accidentally violated by her father on 16 January 2002. There are some factors why the accident occurred due to the reverse parking. Firstly, it is because the driver cannot detect any obstacle behind their vehicles. Other than that, the existing alarm system cannot function efficiently. Lastly, the driver cannot determine the distance between the vehicles and obstacle. Objective for our main project is to help driver to park their car in reverse direction. This is also can help driver to avoid from collision. Our mini project aims to reduce the difficulties to park the vehicle in reverse direction. Next, our mini project also aims to make it easier for drivers to determine the distance between the car with an obstacle behind it through the colors of LED, which is green, yellow and red. That's all from me.
Assalamualaikum, I'm ALIAH HAZIQAH binti Muhammad YUSRI, matrix number 2019218954, and I will be presenting to you about product description and details. Okay, so the main component of our project is Arduino Uno R3. It is a programmable board used to build interactive circuits, and this is the main port for all components to work. Okay, so the next component is breadboard. Breadboard is basically a board that is used to build circuit quickly before the circuit is finalized. By using this board, it can reduce unwanted costs. Moving on to the next component, which is the ultrasonic sensor. It is a sensor that is used to measure the distance between the object and the obstacle. So for this case, the ultrasonic sensor will detect any obstacles when reversing the car. Next is capacitant touch sensor. It is a sensor that detects touch caused by electrical disturbance. For our project, it will only make a sound if we touch the capacitant touch sensor, and in real life application, it can be seen when the car is put to reverse gear. We can hear a beeping sound when we reverse the car. The resistor that we use is 330, and the function of it limit the current flow through another component. Lastly, the component that is used for our project is buzzer. It is used to convert audio signal to sound signal, and the buzzer will only make sound when the object is closer to obstacle behind the car. So the total cost that is used for this project is 75 ringgit 40 cents for 8 different components, which are Arduino Uno R3, small breadboard, ultrasonic sensor, resistor 330, buzzer, wire, jumper male to male, and jumper male to female.
So, Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad, Kamal, Tajuddin, KAMARULZAMIL. So, with an ID of 2019310425. So, I'm going to present to you, continue presenting for our parts on the title of Programming Flowcharts. So, as you can see from the left of the screen, where the programming flowchart, it is started with start functions, and then the arrow goes to the input and output functions, where we have here is 5 output and also 2 input. And for the first one is the 5, which indicates the green LED. The second one is the 4, which indicates the yellow LED. The third one is the 3, which indicates red LED. And the piezo, pin mode piezo, is indicate the buzzer, for buzzer. And pin mode 3, where this one is indicate the trigonometric function from the ultrasonic sensor. And then for the input, we have 2, which is the echo, where the input trigger from the echo functions from ultrasonic sensor. And the last one is the CTS pin, where this input is triggered from the capacitive touch sensor. So as we proceed to the arrows, where it goes to the decisions functions, where I'm using if loops. As you can see here, I'm putting if in a bracket of CTS value is equal to high, which means that if the capacitive touch sensor is touched, then we have 2 results, which is yes and no. So we go to the no, yes first. As you can see from if it is yes, then it will continue to the process functions. As you can see here, it will turn on and off the buzzer with a delay of 500, and also it will trigger the off and on and off of the trigonometric function from the ultrasonic sensor with a delay of 2 microseconds and 10 microseconds. And then for this process, you can see that the there's a 2 formula which is the duration is equal to pulse in equal high, which indicates the duration of the echo sending data through to the Arduino, and then the distance is 0.034 times with the duration divided by 2. For this process, it is triggered to the formula for ultrasonic sensor. So we proceed to the next one, which is if the arrows goes to the decisions functions, where this one I'm using the if loop, where you can see here if in a bracket of distance is not more than 100, so the sensor will detect the distance. If it's not more than 100, then the arrow will goes to the process functions, where the green LED will turn on, while the yellow and red will turn off, and then the buzzer will not going to interrupt will not going to be on. So if let's say the decision is will be no, then it will proceed to the next decision functions, which is if the distance is not more than 30, where this is for the ultrasonic sensor, and then we can see that if it yes, then the process function will trigger, and you can see here only the yellow LED will turn on and the buzzer will still turn off. And if the result is no, then it will proceed to the third decision functions, where if the distance is not more than 10, then if the result is yes, it will trigger the red LED and the buzzer will be triggered to on. But if the result is no, then it will probably goes to the delay, which is the end of the process with a delay to 500. So else, Else, if the what we call the capacitive touch sensor is not on, so it will goes to the no arrow, where it goes to the process of all of the LED will turn off and the buzzer will also turn off. That's for the flow charts of a program.
So we will continue with the circuit diagram. And my name is Muhammad ZUHAIKAL bin Muhammad ZUBIR. Now, as you can see here, we use two sensor, which is touch sensor and also the ultrasonic distance sensor. Here we use three color of LED, which is green light for the safe indicator, yellow light for the warning indicator, and last one, red light for the danger indicator. And also we use three resistor, which is the 330 ohm resistor. Also there is a buzzer to produce sound, which is to make the user more alert. For the output pin, we use pin number 3 connected to the red LED, pin number 4 connected to yellow LED, pin number 5 connected to red LED. And then for the pin number 6 connected to buzzer, pin number 7 connected to eco function ultrasonic, pin number 8 connected to capacitive touch sensor, and last one, pin number 9 connected to trigonometric function ultrasonic. For the input wire, we use the ground wire, we use the ground pin, and then 5-volt pin. That's all from me. Thank you.
So I'm going to be continuing presenting on coding. So moving on to the first slide, which is this is the coding of our projects of a reverse parking. As you can see, for the first line, I'm defining the CTS pin on a digital PWM number 8. So and then I'm putting the variables of constant INT for the piezo, which is for the buzzer, on the pin digital PWM number 6. For the trigonometric functions of the ultrasonic, I'm putting on the digital PWM number 9. And also for the eco, I'm putting eco of the ultrasonic sensor, I'm putting on the digital PWM number 7. For this both is for the ultrasonics. And then for these two variables, I'm using long for the duration and the float for the distance. So we're moving on to the void setup. For void setup, I already explained all these pin mode on the programming flowchart. So as you can see, the 5 for the green LED, 4 for the yellow, 3 for the red LED, piezo for the buzzer, 3 for the ultrasonic trigonometric functions, eco for the ultrasonic eco functions, and the last one will be CTS pin, where it indicate for the capacitive touch sensor. So moving to the void loop. As for the first one, can see that I'm putting the variable of CTS value for the digital read CTS pin, and then I'm using the if loops. If the sensor is touched, then you can see that this is the coding where it will trigger the high and the low. It will trigger high and low on and off on the buzzer with a delay of 500, and then for the trigonometric functions of the ultrasonic, it's off and off with a delay of 2 microseconds and 10 microseconds. And then it will moving to the what do we call duration and the distance, where you can see that this is for the formula of the ultrasonics. And then it will goes to the if loops, where if the ultrasonic sense or calculate the distance is not more than hundreds, then the yellow LED will be on, and then the buzzer will turn off. And if the distance, the ultrasonic sensor detect the distance is not more than 30, then the yellow LED light will be turned on, and then if the distance is detected not more than 10, and then the red LED lights will be turned on, and it will give the high. It will give a high. What do we call high for the buzzer? Sorry. And then the last one else, as you can see here, if the touch sensor is not detected, which means there's no touch on the capacitive touch sensor, you can see that all of the LED will be turned off and the buzzer will not turn on. And all in all of this will end with a delay of 500. I think that's all for the coding. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So my name is Muhammad ILTIZAM Izwan bin SARIZAM, and my student ID is 2019685982. So now I will talk about the result and the discussion. So our input is ultrasonic sensor and the touch sensor. Ultrasonic sensor, the function of ultrasonic sensor is to measure the distance of any obstacle, and the touch sensor is as a switch of our system. And then the output of our system is green, yellow, and the red LED, and the next one is buzzer. So the result of our system: when there is no input to the touch sensor, the circuit will off. And when the input is given to the touch sensor, the circuit on, automatically the green LED will turn on and buzzer emit the sound. So what happened if the distance less than 100 centimeter, which the distance of the back of the car and any obstacle? There is no changes, and the green LED will stay turned on and the buzzer emit the sound. So when the distance is less than 30 cm, the yellow LED will turn on, the buzzer will emit the sound. So this is the code of our system, which is if the distance is less than 30, the digital write pin number 4 will be high, which is the voltage at the pin number 4 will turn high. And then when the distance is less than 30 cm, the red LED will turn on and the buzzer will emit the sound. So this is the code when the distance is less than 10 cm. The digital write pin number 3, the voltage will be high. So this is the discussion of our system. When there is no input given to the touch sensor, nothing happen. And when input given to the sensor, automatically LED green will turn on. When LED green on, it says the distance of back of the car and any obstacle in a safe distance. So the buzzer will emit a sound with a delay of 500 to show the circuit has a current flow. Next, if the distance less than 30 cm, the green LED will turn off and yellow LED will turn on. It as a warning sign to the user. So automatically the buzzer emit a sound with a delay of 500. So the last one, when distance is less than 10 cm, the yellow LED will turn off and red LED will turn on. So when the red LED turn on, it is as a danger sign to user, and then the buzzer emit a sound with a delay of 150, which is faster compare when the distance less than 30 cm. That's all. Thank you.
And last one, we continue with the conclusion. So for our objective, we have successfully achieved the objective to produce a car reverse parking alert system, which is the sensor is function also with the buzzer. And then for the improvised, We can use the higher voltage to produce more sound, and also use the high quality ultrasonic distance sensor. We can minimize the error to detect any object that move near to the sensor. And then for the future, this project we can apply to the industrial car or also the toy car, which is for the toy car is used for maybe for, and for this project also we can apply at the line on the road, which is the zebra cross, which is we can notice, we can alert the car user that their car is near the zebra cross, which is make a danger to the person who cross the road. That's all. Thank you.